Hey everybody, it's Mr. Dollar, otherwise known as Peace Daddy, and today our lesson's going to be on the multiplication checkerboard. The multiplication checkerboard is a lesson that will allow the child to see a geometric representation of multiplication. It's also going to allow the child to understand the role that place value plays in multiplication. So let's get started with our lesson. There is the multiplication checkerboard. So you will probably recognize some of the parts of the multiplication checkerboard if you've been in a lower Montessori class and you're now in an upper Montessori class. One of the first things that you'll notice is that the colors coincide with the place value. So the 1 is always green, the tens place is always blue, the hundreds place is always red, and then the pattern's going to repeat itself. Green, blue, red, so that 1,000 is green, 10,000 is blue, 100,000 is red, and so on. So let's explore this and use our unit beads, our bars over here, to talk about it. I'm first going to start out with one red unit bead, and I'm going to place it on the square with the 1 written underneath it. Its value is 1 when it's on this square. Now I'm going to put it on the square that has 100 on it. And now its value is 100. If I put it on the square that has 10,000 underneath it, the value of that one red bead is 10,000. So as the bead moves, the place value changes and the value of the bead will change. This is a 3 bar, and this bar has a value of 3. If I move it up to this square, now it is worth 30. On that square, it is 300. And on the last square, if I move it all the way up to this square, its value is 3,000. So it should be clear that the bars take their value both from the actual value of the bar, this is a 3 bar, and from the position that it's placed on the board. So if I put this bar here, think for a minute and see if you can come up with the number. The value of this would be 300. 300. All right, let's try another example. I'm going to take a 4 bar, a 5 bar, and a 3 bar. And put the 4 bar in the red square, the 5 bar in the blue square, and the 3 bar in the green square. And if you're thinking about that number, it is 453. Now I'm going to move them up just 1 row so that now they're on this row. Think about how that changes the number. Now it's 4,530. Why'd that happen? That happened because we moved up 1 row. Everything in this row is 10 times everything in this row. If we move it up all the way to the top, row up here, the value is 453,000. Everything that's in this row, this top row, is 1,000 times as much as it would be in the bottom row. If I move these down one row, it's as if I'm dividing by a factor of 10. This is now 45,300. So by moving them down one row, I'm dividing by 10, and every time I move up one row, I'm multiplying by 10. So now let's talk about, there's going to be two different words that we're going to use, which are slide and exchange. So I'm going to show you with a problem how to do a slide and how to do some exchanging on this board. The problem to be worked out is 4,327 multiplied by 23. So on your paper, write down the problem. 4,327 multiplied by 23. So there's a couple of norms that we have to establish as we're working with this material. The first one is that the first problem always goes on the bottom of the board. And that problem always, that number always uses the light colored tiles. So we're going to put 4,327 on the bottom. 4,000. And the 4 has to be green like the green tile. The 3 has to be red like the red tile. The 2 is going to match the color blue that stands for 10. So we're going to have a blue 2. And then we need a green 1 or 7. A green 7. 4,327. Green 4, red 3, blue 2, green 7. And we're going to take that 23 times. So now we're going to use the darker colored tiles. And the 2 goes here, and it's blue. And the 3 goes here, and it's green. Okay. So first, there are 7 units to be taken 3 times. So I'm going to place 3 bars of 7 on the green square in the lower right-hand corner because we're taking 7 3 times. So I'm going to get 3 7s. 1, 7. I'm taking 7 1 time, taking 7 2 times, taking 7 3 times. And that stays in the green square. Next, I'm going to take 2 3 times. So the bar is going to change because the number changed, but the number of times that I'm taking it is still going to stay the same. So I'm going to have 2, the 2 bar, and I'm going to take it 3 times. Now I'm going to take a 3 bar 3 times. And then a 4 bar 3 times. So each time, if the number tells me to change, I'm going to change the bar, but I'm not going to change the number of times that I take it. So notice that there's 3 7s, 3 2s, 3 3s, and 3 4s. Okay, and I didn't do it, but usually the way that you do it is if you're not multiplying by the 10, this tile is turned over, and that helps you to remember that we're not doing anything with this tile. So when I'm done with the 1s, I can turn that tile over and turn the 10 over, and now I'm just working with the 10s up here. That might help to remember which row you're working with. So we're going to do the same thing, but now we're in a different row and we're using a different number. So we're taking 7 2 times. So I simply get 2 7 bars, put them in the blue square. Now I'm going to be working with the 2s again, but I'm only taking 2 2s this time. They go in this red square. I'm working with the 3s again. I need 2 of them. They stay in this green square. I'm working with the 4s this time, and I need 2 of them. So 2 4s are going to go there. Okay, so that's the easy part. Now, another easy part, but it's the second part of the problem. When you're done, you can go ahead and turn that back over, indicating that all the work is now done. We're finished with the 1s row, and we're finished with the 10s row, and now we're going to do the slide. So in order to do the slide, you take everything that's on this 10s row and you slide it down to the 1s row, but you keep it in the same color. So if it was on the blue square here, it's going to stay in the blue square on the 1s row. So I'm going to move everything that's green to this green square and make sure that it stays there. You got to be very mindful. This board is soft and smooth, so things have a tendency to roll on them if you're not careful. Just keep everything from the red in the red and everything from the blue in the blue. So now we have completed a slide. So we did the first part where we did all the multiplication. We did the second part where we did the slide. Now we're going to do the last part, which is the exchange. So I'm going to start always on the right. Start over here, and I'm going to add up all the numbers. If you already know that 7 3s is 21, then you can just pick this up and change it to a 2 and a 1. If you didn't know that 7 3s is 21, that's okay, because you can count the beads like you've done many times before. You just get a counter, start here, count out 7, and then begin on the second row until you get to the correct number, which is 21. So now I'm going to take these 3 beads of 7, which is 21, and exchange it over here for 21. The thing to remember is that you're only allowed to have 1 bead in each square when you're done. So the 1 is the only thing that's going to go in this square, and the 2 that represents 20 goes in the square next to it, the blue square. So 21. And then you just continue along, exchanging in each square. Here I have 2 7s, which is 14, and I have 4 2s, which is 8, and 14 and 8 is 22. So I'm going to exchange this for 22. 2 7s is 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. The 2 goes here for 20, and that 2 goes there for 2. 3 3s is 9, and 3 2s is 6. 9 and 6, 15. So I'm going to exchange that for a 1 and a 5, which makes 15. The 1 goes in this square, the 5 goes in this square. You're only allowed to have 1 bead in each square when you're all done. In this green square, in the 1,000 square, I have 4 times 3, 4 taken 3 times, which is 12. And then I have 2 3s, which is 6. So 12 and 6 is 18, and 1 more is 19. So I'm going to put 19 a 1, and a 9. 19. Last one, 2 4s is 8, and 1 more is 9. I have 1 bar in each square. So my answer is 99,521. 99,521. So on your paper, you would write 99,521. And this is known as the first passage. And if you tune into the next video called Multiplication Checkerboard Passage 2, I'll show you a way to do the problem that is the next level of abstraction. Once you've mastered this way, the next lesson that you're going to look for is called the Multiplication Checkerboard Passage 2. This was the first passage. Thank you very much for watching. This is